Welcome to our second multiple choice Monday chemistry question. If you've not had a chance to answer the question, pause the video now and check the answer before moving on. So how did you do? The correct answer this time was D. These three flasks contain the same number of gas molecules. This question's a little bit harder than last week, so let's just go through what the other three options, why they're wrong, why they've been included. So we've been told there are three flasks. We've been told that they have the same volume, and other important information from the question is that they are at the same temperature and pressure. And so when I take all these three pieces of information together, that tells me that we have the same number of moles of gas. And when we say number of moles, moles, remember, is a way of counting particles. So if my gas was made of individual atoms, then each flask would contain like the same number of moles of atoms. But I've actually been told another piece of useful information in the question, which is that each of these gases are compounds. So the best thing to do to see why the other options are wrong is to choose three different compounds and look at how that applies to the question. So I'm going to go for three gases. I'm going to have to choose three compounds that I know are gases at room temperature. CO2 is an easy one to start with. Another one that would be easy would be methane, CH4, and while I'm on alkanes, I might as well just choose a different one, C2H6. So all of those are gases at room temperature. Now let's look at A. A says they contain the same mass of gas. Well, hopefully we can quickly realise that because each of these compounds has a different relative formula mass, that there is no way that if they have the same number of moles in each flask, they will contain the same mass, because CO2 has an MR of 44, methane has an MR of 16, and ethane has an MR of 30. So it doesn't mean that they all contain exactly that mass, because we don't know actually how many moles they contain, but we do know that they don't contain the same mass if they are the same number of moles. So A is out. B says they contain 0.1 mole of gas, and the reason this question is here is because they're relying on you using a quick shortcut in your head, because you should know that 1 mole of gas at room temperature and pressure occupies 24 decimeters cubed, which is equal to 24,000 centimeters cubed. Now that's at room temperature and pressure. These flasks could be at room temperature and pressure, but even if they were, if you actually do the calculation, 240 centimeters cubed would not equal 0.1 moles. 240 centimeters cubed would actually equal 0.01 moles of gas. Either case, the question doesn't actually say that it's at room temperature and pressure anyway, so we can't make assumptions about that. And then in part C, they contain the same number of atoms, so that sounds very, very similar to part D. So let's just think about these gas molecules for a moment. These are all covalent compounds. They'd have to be covalent because it's a gas. CO2 is made up of carbon atom combined to 2 oxygen atoms. CH4 is contained by a carbon atom and 4 hydrogen atoms. I'm not colour coding the atoms here. And a C2H6 molecule is going to look like that if I was just going to sketch out the molecules. So one thing you can see there, when we say that they have the same number of moles, let's say, for example, that it's room temperature and pressure and there's 0.01 moles of gas. That means that they have the same number of particles. Now the smallest particle of all of these compounds is a molecule, which is made of atoms joined together. So 1 mole of CO2 will contain 3 moles of atoms if I was to count individual atoms. 1 mole of CH4 would contain 5 moles of atoms because there are 5 atoms per molecule of CH4, and 1 mole of C2H6 would contain 8 moles of individual atoms if I was counting them. Normally we don't count individual atoms, that's why we use moles to talk about numbers of particles and not number of individual atoms, because it doesn't make sense. The atoms are joined together in a compound. So that is why C is wrong. They will contain the same number of gas molecules. If I wanted to work out the number of gas molecules, I would take, if it was of room temperature and pressure, my 0.01 moles, and I would times it by Avogadro's number, 6 times 10 to the 23, and I would therefore find that there were 6 times 10 to the 21 molecules of each gas.